This is AQA A-level Chemistry, so multiple choice question on electrode potentials. Pause it, have a go, and then review. So on this one, I am going to go into quite a lot of detail on the answer. You don't necessarily need to write down everything that I'm going to do, but I'm going to start by putting all of the half cells into a number line collectively, because that's going to allow us to see in every possible combination what would be on the left and what would be on the right. I can see here that with the Fe2 plus Fe3 plus and MnO4 minus Mn2 plus, the iron half cell would be on the left hand side, which means it would undergo oxidation, which means we would reverse this half cell. And that therefore means that A is true. The iron 2 is oxidized to iron 3, the MnO4 minus is reduced to Mn plus 2. If we then take a look at the second one, where we have got dichromate 6 oxidizing iron 2 to iron 3, again, iron 2, iron 3 half cell is on the left hand side, so oxidation does take place. By oxidizing it, we have got the dichromate 7 being reduced to chromium 3. If we move on to the next one, it's actually slightly more complicated than this, because we have got zinc reducing chromium 6 to chromium 3, but it can also reduce chromium 3 to chromium 2. So that would happen. The zinc would be oxidized, because it's on the left hand side, to Zn plus 2. And then finally for D, we're going to look at this in a little bit more detail. I'm going to take the two examples and just put the number line up for those. And let's look at what would happen. What is the feasible reaction? Well, electrons would flow from the left to the right, as is always the case, the more negative to the more positive. That means that we would need to reverse the chromium half equation as part of our reaction, and we would keep the Fe3 plus being reduced to Fe2 plus. Now from there we can put an equation together to show what it looks like. What we can actually see here is that the reverse is true of the statement in D. Therefore, the correct answer, being incorrect, is D.